Alright, you guys, we got a little bit more to do. Here is the general form of recursive rule, right? You give an F1 and then you write a rule, alright? To write a rule, you need to know that you have to start from the previous statement and then the difference. Here is the general form for an explicit, right? You give a start and then a rule of n minus 1. Let's go down here and explain it. Ready? F1 is my start. My start is 0. To get my common difference, all I do is I take any term, like 16, and I subtract the term in front of it, like 8, and that gives me 8. So now I have a rule and a difference, and now it's just the spot of putting it in the right, the concept of putting it in the right spot. So here we go. All right. Recursive rule, you write where you start, 0, and then you write your rule. To find your term, you take the term in front of it and add your difference of 8. And this only works for terms bigger than the first one, right? Because we have to have the first term to get the second to get the third. So you write that. Now explicit rule is a little different. You still say your start of 0. And then you say, hey, you know what? I'm going to add 8 every term after the first term. Because I don't want to start adding until I get to my second term, right? Because if I added 8 on the first term, I would not have 0 anymore. So on the second term, I add 8. In the third term, I add 8 more. So we're almost there. What is the recursive rule for this sequence right here? Alright. How do you know? So the recursive rule for this sequence right here, right? It is this, right? It is 2. There's my start. The recursive rule is to add -3. Alright, because that is what changes every single time. As I go up, I go down 3. Alright. There's my start and my rule. Right, a recursive. So here we go. I'm going to do everything that we need. We need our F1, which is my first term of 6. We need our difference. Right, and to get to the difference, all I do is I take any term, like 16, and I subtract the other term, 6. And I get a difference of 10. But look, 26 minus 16 is 10. 36 minus 26. So it doesn't matter the one I pick, as long as I do the one after it or before it to figure out my difference. Alright, any term subtracted from the one right after it, and you will get your difference. So here we go. Once I get my recursive rule, I write my recursive function. So let's write recursive. Recursive has a rule, which is F1 equals 6, and then it has, a start, now it has a rule. To find my term, I take the term in front of it and do my difference, add 10. Just like that. Explicit, very similar. To find my term, I start at 6 and I add 10, n minus 1 times, for n is greater than or equal to 2. Cool? We're going to come down here. There's an example. I want you to look at the example, but we're going to skip to 169 and do this one. So here we go. Look. We're going to write a rule for this. First we write our numbers. That's 1, 6, which is right here. 2, 9 is right here. 3, 12 is right here. 3 and 12, and 4 and 15. I can find my difference, but we're going to do it every possible way. I did 9 minus 6. Right? 9 minus 6 is 3. This says F3 minus F2, so 12 minus 9. Any number, subtract the one in front of it. 3. Next one's going to be 15 minus 12. So I have a common difference. They're all the same. My common difference is 3. We can see it, right? So for an explicit function, I'm going to substitute 6 for F1 and 3 for D. Here it is. Explicit, I have my term of 6 plus 3 to the n minus 1. Let's do recursive since we're at it. Recursive. Recursive, I write F1, right, equals 6, and then I say to find a number. I take the number right in front of it, and what's our difference? We add 3. We're going to add that these two graphs, x and n, are the same graph. So we can do one more. The last one. We're getting there. All right. Jerry collects hats. We can see these rules right here, right? I'm going to write my points. I've got 110. Looks like we've got 218. We're going to see what these mean. And then we got 326 and 434. So let's see. The number of hats in his collection depend on how many years. So my X values are years. And after the first year, where he starts with 10. Each year he adds the same number of hats to his collection. The graph shows that sequence, so we need to write an explicit rule in function notation for the arithmetic sequence. So we're going to say, let's find out all our information. F1 equals 10, and our difference is any output minus the previous. So maybe 18 minus 10 is 8. But again, I could do 26 minus 18 or 34 minus 26. So I'll get a difference of 8. Even though it only asks for explicit, we're going to do both. We're going to do recursive and explicit. For recursive, I give my start, which is 10, and then I say to find my term, I take my previous term, and minus 1, and I add, what's my difference? 8. For explicit, much easier. I say to find my term, I start at 10, and I add 8, n minus 1 times. And we're done. I'm going to post this, and we'll see you soon.